Good morning, students. In the last lecture, we have studied the synthesis of the isoquinolines, and from earlier to that lectures, we have studied the synthesis of the quinolines. So these two, quinoline and isoquinoline, both part is important. One of the questions will be asked on this two synthesis. In this two synthesis, starting material is most important to remind the mechanism synthesis part and the steps involved in that parts. In the isoquinoline synthesis, in the last lecture, we have studied the synthesis by using the benzaldehyde, along with the nitromethanes. So this is method of preparation of the isoquinoline is called as Bisler-Naplasky synthesis, and the synthesis of quinoline is called as Skyrov synthesis. So these two syntheses are the important parts. These two synthesis part will ask questions on the basis of the name of the synthesis, and sometime will be asked by the which we are going to be formed. So question will be asked by 2 or 3 different ways, but the answer will be the same, and the synthesis part will be the same. So do regular revision of the synthesis part, starting material and the final product, and the step involved in it. Now we proceed further. In the current lecture, we are going to study the reactions of these heterocyclic compounds, that is pyridine, N oxides, quinoline, and isoquinolines. So reaction part is same. We know that the nature of that particular rings. If you know the nature of the particular rings, then we can easily understand where the reaction is going to be takes place. The maximum types there is a substitution reactions takes place. Sometimes there are electrophilic, sometimes there nucleophilic substitution reaction takes place. So these two reactions are most important because this is the main aromatic ring systems. On the aromatic ring system, additions cannot be easily possible, substitutions easily possible. So substitution reactions takes place. So first reaction is the chlorination reactions of pyridine and oxides. For the chlorination of pyridine and oxides, we use the reagent that is SOCl2 along with the POCl3. The pyridine and oxides react with the SOCl2, give the product at the 2 and 4 positions, because we have studied that the 2 and 4 positions are more favorable. 2 and 4 positions are more favorable for the nucleophilic substitution reactions. So in this case, nucleophilic substitution, electrophilic substitution reactions takes place. So this is the basic reactions, we can understand it easily. So this is the nucleophilic. It is the electrophilic substitution reactions. So is the mechanism part is given here. We can easily write. I will show you how to write. SOCl2 is the reagent, chlorinating agents, and POCl3 help for the chlorinations. So two positions are most important where the electrophilic substitution reactions takes place. One is the first, fourth, and sixth positions. So reactions give the product, one product at the Cl, second as that Cl. So these are the two important reactions. Chlorination takes place. Simple reactions. By the same ways, the second reaction, that is bromination reactions. In the bromination reaction also same procedure is followed. That is the substitution takes place at the brominations Br2. Here is the bromination takes place at the 3 bromopyridine and oxide 3 positions. So we can write down the bromine on the third positions. If you use the zinc dust, then reduce the ring oxygens and form the pyridine ring. This will be formed in these reactions. So this is the brominations. For the brominations, brominating agent is Br2 is used. Br2 is the brominating agents. Next one is the nitration reactions. For the nitrations of the pyridine N oxide, nitrating agent used, that is the concentrated H2SO4 and concentrated HNO3. Concentrated H2SO4 and concentrated HNO3 are added at the fourth position. Next one is the nitrations. So nitrating agent is concentrated H2SO4 plus concentrated HNO3. These two are the nitrating agents. So in the reactions, this is the nitration reactions. Always remind that whenever there is a nitration reaction, nitrating agent is always fixed. That nitrating agent is the concentrated H2SO4 plus concentrated HNO3. These two reagents are used for the nitrations of the aromatic compounds in the maximum cases. So this is the nitrating agents. Next is the amylations. Means amine group is going to be added on these reactions. We know that whenever there is a suffix at the any reactions, suffix ation means that particular chemical compound, a particular reagent going to be added on this reacting materials. Earlier we have studied the bromination, means bromine is added on the materials. Now is the amylation, means amine is added on the structures. So these are the starting materials and these are the adding materials on the reactions. So in the aminations, the aminating agent is the liquid NH3 and NaNH2. Liquid NH3 and NaNH2. These are two are the aminating agents added at the 2 and the 3 positions. So this is the reactions, general reactions. We can write down it. At the 2 position, that is 2 amino pyridine and oxide, this is on the 2 positions, and the same will be add on the 5th position also. 5th position also. This at the 3rd position, that is 3 amino pyridine and oxide. These are the two reagents going to be added on the 2 position, that is 2 amino pyridine and oxide, and 3 position, that is 3 amino pyridine and oxide. These are the two reagents going to be added on the 2 and 3 positions when we are doing the amination. So please reminds, if you going to confusing the while studying this, to do practice regularly. If you do practice more and more times, you can easily understand the where is going to be the substitution reactions takes place. So next is the reagents used to form the COOH groups on the ortho positions. So for the carboxylations, means carboxyl group additions, firstly there is a formation of the um, anions, or there is a attachment of the lithium group. So this reaction is also the crucial reactions in the reactions. The reaction takes place with the reagents, that is N-butyl lithium strong base, that is N-butyl lithium, where lithium is going to be added. N-butyl absorb the proton, abstract the protons, and where their attachment of N atoms lithium, this takes place, means here is the formation of the negative charge at this position. This negative charge going to be added on the CO2 groups. So CO2 groups get converted into the COOH, means the formation of the compound, that is N takes place, that is COOH. Next one is the reaction of quinolines. This is all about the reactions of the pyridine oxide. First reaction is the chlorinations. For the chlorination of pyridine oxide, the reagent SOCl2 is used along with the SOCl2. The POCl3 is also used as the Lewis acid. So it helps for the reactions, and the substitution reactions takes place easily, and at the position 2 and 3, so that we will get the 2 chloropyridine and the 4 chloropyridine as the two products. So next reaction is the bromination reactions. So for the bromination of pyridine and oxide, brominating agent used is the Br2, and along with the temperature is important, that is 72 degrees centigrades. The bromination takes place at 3 and 3 positions, and the product form is the 3 bromopyridine oxides, and the removal of the oxygen, that zinc dust are used that remove the oxygen atom attached to the nitrogen atom, so you will get the 3 bromopyridine. Next reaction is the nitration reactions. In the nitration reaction, nitrating agent are used. That nitrating agent is the concentrated H2SO4 and the concentrated HNO3. This gives the nitration at the position 4, that is the 4 nitropyridine N oxide as the product of the nitration of pyridine N oxides. Next is the amination reactions. In the amination reaction, aminating agent is the liquid NH3 along with the NaNH2 sodium nitride. So we'll get the product at the 2 positions and the 3 positions. So product will be 2 amino pyridine N oxide and 3 amino pyridine N oxide as the product. Fourth is the pyridine N oxide react with the N-butyl lithium, gives the substitution reactions and form the lithium pyridine N oxide, and along with the CO2 groups gives the addition of the CO2 at the lithium positions, so we will give the COOH. So this is all about the reactions of the pyridine N oxide. In the next lecture we will study the reactions of the quinolines. Friends, do the practice of these reactions at home, because without practice you cannot complete these reactions. Practice is the key for the organic chemistry. Always remind that chemistry is a volatile subject. It removes mind from the mind easily. So do the practice, and after practicing you can easily remind the reactions how to write and how to perform, write the theoretical part also. So the friends, we will meet in the next lecture. Thank you very much.